In this lecture, we discuss about the reducible to linear differential equation. So the first equation which can be reduced into the linear differential equation is Bernoulli's differential equation. A differential equation of the form dy dx plus py is equal to q whole multiply with yn is called as Bernoulli's differential equation. Now, if we divide equation by y to the power n and substitute y to the power 1 minus n is equal to u, then 1 minus n, what is the derivative of 1 minus y to the power 1 minus n is 1 minus n, y to the power 1 minus n minus 1, y to the power, what is let me just tell you, y to the power 1 minus n, its derivative with respect to y, with respect to x, sorry, not y, x. So 1 minus n y to the power 1 minus n minus 1 and dy dx. So this plus 1 minus 1 will cancel. So we have 1 minus n y to the power minus n dy dx. So now if y to the power y to the power 1 minus n equal to u, which gives us 1 minus n y to the power n minus 1 dy equal to du dx, then we get du dx plus 1 minus n pu, which is equal to 1 minus n q. This is the first, this is what it is, nothing but the linear differential equation in u and x. Similarly, if we have given a differential equation of the form dx dy plus px is equal to q into x to the power n is called as Bernoulli's differential equation. Here, if we again divide by x to the power n and put x to the power 1 minus n, which is equal to u 1 minus n x to the power minus n dx dy is equal to du dy, and then the given this equation will be converted into the linear differential equation du dy plus 1 minus n pu, which is equal to 1 minus n into q. This is again a linear differential equation. So this is called Bernoulli's differential equation. Though in the first part, here y is dependent variable and x is independent variable. In the second part, x is dependent variable and y is independent variable. Now there is one more type of equations. The first thing, the third type of equation is equation of the form f dash of y dy dx plus p into f of y equal to q are at once reducible to linear form by substitution f of y equal to u and f dash y dy dx is equal to du dx. So now in this case, if you put f of y equal to u, then f dash of y dy dx is nothing but du dx. So it will transfer the equation into du dx plus pu, which is equal to q, which is nothing but a linear differential equation. Similarly, if instead of y it is x, let us see here f dash of x dx dy plus p f of x, which is equal to q, are at once reducible to linear form by substitution f of x equal to u and f dash of x dx dy, which is equal to du dy, transforming the equation to du dy plus pu, which is equal to q, which is again a linear differential equation. So now these are the four different, or we can say that only the two types of equation that can be reduced into the form of linear differential equation. Thank you.